In this video, we're going to add a function to our linked list implementation that allows us to delete a node from our linked list. So we have the ability to insert, now we'll have the ability to delete. So I've already opened up the files that we'll be modifying in this video. So I have contactlist.h, contactlist.cpp, and contactlist.app.cpp opened up. If you need to take some time and open up those files, you can go ahead and pause this video and then resume it. So the first thing that we need to do is add in a function prototype here to contactlist.h. So right below our insert function prototype, we'll do our delete function prototype. So it'll be a void returning function, and we cannot call it delete, and the reason why is because delete is a keyword in C++, and we'll be using this keyword a little bit later to actually delete a node. So we'll just call it delete node instead. And for the formal parameter list, it's going to be exactly the same as what we had for add to head and insert. So we'll be passing in a name. If you remember, each one of our contact nodes has a name data member. So we'll just pass in a name, and we'll pass it in by constant reference. So we'll have const std : string here for our formal parameter list, and then a semicolon. So you can go ahead and save that there, and then we'll move over to our contactlist.cpp file and start writing our actual function definition. Alright, so what I'm going to do is just write our function definition right here below our insert function. So let me just scroll up a little bit. So that was our insert function here, and now we'll be writing our delete node function. And as we write this delete node function, you'll see a lot of similarities in its structure to what we had for our insert function. So if you watch that video, you should be like, oh, this looks really familiar. So this is a void returning function. It belongs to our contact list class. It's a member function, so we should be able to use our scope operator and select delete node, and then specify const string ampersand there. So we're passing in our name there by constant reference, and now we can write the body. So the first thing that we got to look for is if we're in the case here. So we'll say this is case 1. If we have an empty linked list, so an empty list, and the way we check for that, as you know, probably, we check to see if the head pointer is equal to null. So if our head pointer is equal to null, we know we have an empty linked list. And what we're going to do for the delete, there's no way for us to delete anything from an empty linked list. So we'll just tell the user with a cout statement that the node cannot be deleted from an empty linked list, or we'll say an empty list. And then we'll have an mdel here, and that's going to be it for the if part. And then if we get past that part, we know at least we have one node on our linked list, so there's potentially some stuff in there that we can traverse through. At least do one comparison and find out whether the name that they passed in matches the name for that particular contact node. So it's just like what we did for insert. What we need to do, let me scroll up a little bit. We need to do a traversal. So the first thing that we're going to do is declare these current and trail pointers. And if you wanted to, you could just copy and paste that bit, and we could do some modifications, but I'm going to type it out. So we'll do contact. We have a contact pointer called current, which is abbreviated to cur, and we'll set that to the head. And we have another contact pointer called trail. This is going to be one node behind our current pointer, so it's initially set to null. And then what we'll need to do, now that we have those pointers set up, is to traverse through our linked list. So we'll have this looping structure. So let me go ahead and write a comment here. We'll do a traversal. So traverse list to find node to delete. That's the action that we'll be doing next. So in order to do that, we need to set up a while loop. So it's going to be while our current pointer is not equal to null, meaning that we haven't fell off the end of our linked list. Then what we're going to do is just do a comparison where we'll see if our current pointer's name, so whatever node we're currently pointing to, if that particular node's name is equal to the name that we passed in. So if those things are equal, then we can go about breaking out of our looping structure because we found the node that we need to delete. Now if that turns out not to be the case, we'll have an else statement here, and in the else statement what we need to do is continue looking, and the way we continue looking is by driving our current pointer forward, and our trail pointer needs to come forward too. So the trail will end up pointing to what current is currently pointing to. So trail will be updated first. If we don't update it first, then it won't make any sense. So we'll have trail set to current, and then we'll have current set to current's next. Okay. So that's all the code that we'll need inside the while loop structure. And we get kicked out of this while loop for one of two conditions. One is we found a node that has the name that we're looking for, so we get a match here and hit this break statement. Or we traverse through the whole entire linked list and we end up having our current pointer pointing to the null value. So let's go ahead and here below the while loop, we'll test for case 2. And case 2 is going to be the case where we've went through the whole entire linked list and we never found a node that had a match for the name that we were looking for. So case 2, we'll have node with name, and maybe I'll put name in quotes, node with name, not found in list. So the way we check for that is just like what we did before whenever we were looking at an empty linked list, except now we'll check to see if current is equal to null. And if current's equal to null, we know we went through the whole entire linked list and did not find the thing that we were looking for. So we'll just output to the user using a cout statement that we'll say contact with name, colon, and then output whatever the name is. And then we'll say not found. And then we'll do an indel here. And that will be good for our case 2. And maybe I'll go back up here to case 1. Instead of saying node, maybe I'll also say contact here as well. So we'll say contact cannot be deleted from an empty list. Okay, so if case 2 turns out not to be true, so current is in fact not equal to null, then we know that current is going to be pointing at the node that we want to delete. So I'm going to have an else statement here. So we'll say else, and we really have two different cases or two different conditions that we're going to deal with. One is if we're at the head node, so current's pointing at the head node, so we want to delete from the head, so we'll call that case 3, and that's a delete from the head node. And then the other case, as you may imagine, case 4 is going to be a delete from beyond the head. We'll say delete beyond the head, so somewhere after the head node. So those are the two cases that we need to deal with. So the first case here, the way we check to see if we're at the head node is just to check to see if head is in fact equal to current, or you could say if current is equal to head. And we need to do something there. And what I'm going to do now is go and draw pictures so it's perfectly clear what code we should be writing for case 3 where we're deleting from the head and case 4 where we're deleting somewhere beyond the head. So if you can draw a picture, you can easily write the code that needs to go in these two places. So let's go draw some pictures and then come back and we'll write the code. Okay, so let's assume that we have this scenario where we're trying to delete the node that has the name April. So we would have our traversal going on where we initially set our trail pointer set to null and our current pointer would be set to the head, and we would find out straight away that the current node's name matched the name that we were looking for. So then we would break out of our while loop, and now we would be looking at our cases there, and we know that we're not dealing with a case where current is equal to null, since current is equal to head. And so since current's equal to head, we're dealing with that third case where we're trying to delete the head node. And what we need to do is be able to update head, because we don't want to delete this node here before we've updated this head pointer to point here. And the way we go about accomplishing that is by using this next pointer here. So next is already holding the address of this particular node here. So all we need to do is use heads next, or you could say current's next, heads next. That needs to be set to head. So we would have a bit of code like this. We'd say head is going to be set to heads next. And once we have that, we would then update our picture. So let me update our picture here so that head is going to be pointing here to heads next. And now, once we've done that, we've isolated this node here for deletion. So we can now delete this node here that's being pointed to by our current pointer. So we'd write some code that looks like this. We would do a delete, and what we would do a delete on is the pointer cur. So cur is going to be pointing to the thing that we want to delete. So whenever we do this delete here, it doesn't actually delete the pointer, the delete operation, but it deletes what the pointer is pointing to. So this bit of code here would end up deleting this business here, this node, out there on the heap. So now let's take a look at an example for our fourth case where we're trying to delete something beyond the head. Okay, so let's look at this example here where we're trying to delete the node that has the name Mary. So I've already done the traversals and got our trailing and current pointer in the correct position. So we have current pointing at the node that we're interested in deleting. It's not our head node, so we're in case 4 there. And we have our trail node pointing at the node right behind the current node. So what we need to do before we actually do the delete here on current to remove this node, we need to adjust our pointers so that this node here's next pointer is pointing here to this Tom node. So the way we go about accomplishing that is by setting the trail pointers next, so this pointer here, to current pointers next, which is pointing to this Tom node here. So this current pointers next simply holds this address, and we want to set trail pointers next to also hold that same address. So it's just going to be some code that looks like this. We'll have trail pointers next, so trails next is going to be set to curs next, so current pointers next, and that will adjust the pointers like so. So let me go ahead and erase this bit here, and it will adjust that pointer so that it's pointing here to this node. So it's pointing there to the Tom node. And now once we have that in place, we can go about doing our delete operation where we do a delete on cur. So as soon as we do a delete on cur, it's going to remove this node here. So I'll go ahead and mark that node as being removed. And that's pretty much what's going on there if we're in case 4 where we're trying to delete from not the head but anywhere else in our linked list. And it would be the same case even if we were trying to delete this Tom node. So let me just go back a little bit. If we were trying to delete the Tom node, we'd be in a situation where trail would be pointing here and current would be pointing here, and we would just be updating our pointer for this Mary pointer here, or Mary's next, to point to null instead, which is exactly what we want to have. So it still works out there even if we're trying to delete from the tail as opposed to somewhere else other than the head. So let's go back over to Eclipse and implement this code. Okay, so back over here in our contact list.cpp for case 3, what we'll have there is just setting our head node set to heads next. So this is back whenever we're trying to delete from the head, and we want to set head to heads next. And that's the only thing that we'll have to do there for case 3. And then for case 4 here, so case 4 is going to be in our else statement here. So we'll have else, open brace, close brace. Let me close this up a little bit here so we don't have so much space there between those two. And in the else part here, we'll have trails next. So we're setting trail pointers next to be set to curs next. And again, that works even if we're trying to remove the very last node in our linked list. And so that's all that we need to have. And since in both of those cases we want to do a delete on cur, then we can just go here inside of the else statement, but outside or inside the else, but after the if else inside the else. So here's the else that I'm referring to. So down here right after the closing inner else, we'll do a delete on cur, and that actually deletes the node, and then we'll also decrement the size. So we'll decrement the size there. So these were the only two conditions where we're actually deleting a node, where we actually found the node that has the name that we want to delete, and now we're performing the delete and also decrementing the size. Alright, so that wraps up everything that we need to do for our delete node. So we've handled the case for an empty list. We've been able to traverse through our list to try to find the node that we're looking for, and then we have a case to test to see if we did not find a node that had the name in it, and then we also have our two cases for deleting at the head or deleting some node beyond the head. So let's go ahead and save this file, and then we'll go over here to contact list app.cpp, and in here we have a while loop in which we ask the user to input a name to add into our list. So we have that, and what I'm going to do is just copy this bit of code here, and maybe I'll leave it up to an exercise for you guys to work on, is to maybe make these two into function calls. So copy this into a function for being able to create a list, and this would be a function call for deleting stuff. So this is probably not good programming here just to have these two looping structures inside the main. We'd probably prefer to have function calls there, but I'm going to leave that up to you to perform as an exercise. So let me change this bit of code here where I'll say enter the name of the contact to delete or Q to quit. And here, instead of doing a delete an insert operation, we'll do our delete operation. So we'll say delete node. And also I'm going to pull this bit of code here dealing with our print statement inside of this while loop structure so that we can see how the list is being updated after every single delete operation that we perform. And I guess we could do the same thing for the insert, but we've really already tested that out. So I'm going to go ahead and save this and build it just to see that it builds okay. And it looks like everything's building okay. So now I will run this and test it out, see how it works. So it says enter the name of the contact or cue to quit. So we'll have maybe David here. We'll have Mark. We'll have April. So I'm just adding in names in whatever order. Our insert should be putting these in alphabetical order though when it does an insert operation. We'll do, let's see, who else do we want to have? We want to do Larry, and we'll also do maybe Paul. And then we'll do cue to quit. And now we want to enter in a contact to delete. So let's go ahead and maybe delete Larry from our list. So you can see that our list no longer contains Larry. And then we'll do a delete for David. So delete David. And you can see the list doesn't have David, and we'll delete Paul. Paul's at the end of the list. We can delete April at the beginning of our list. And now I'm going to specify a name that's not even in the list. So I'll specify, maybe I'll specify David again. David's no longer in our list. So it says here, contact with name David not found, which is what we'd expect to have. So Mark is still in our list. So let's go ahead and delete Mark. So we've deleted Mark, so our list no longer has any names in it. And if we were to try to delete anything now, we would, like, let's try to delete Mark again. It's going to say contact cannot be deleted from an empty list. So it looks like the program's performing exactly the way we'd expect it to perform. And I would encourage you to maybe play around with it a little bit. Certainly maybe turn these two bits of code here where we have these while loops into function calls and just copy this code into a function body. The other thing that I'd encourage you to do is maybe play around a bit with a debugger and just see how things are going on in memory and seeing how those pointers are getting updated with the proper addresses. So that's it for this video.